In this video today, what you're going to be doing, class, is to look at two graphs. We're going to graph y equals, first off, the sine of theta, then secondly, y equals the cosine of theta. And what you'll probably want is that unit circle we worked on in class the other day. So if you have that handy, it'd be helpful. Next thing we would do, actually graph those two things, is talk about what's the period and the amplitude for these functions. Now we're not dealing with the tangent yet. We're going to start with the sine, cosine, and do a couple things with that. Talk about its period, amplitude, and in class on Monday do some additional things with not just the sine of theta, but we'll put different coefficients in front of the theta and see how that affects it. But to start with, those are the two we're going to do tonight, do while you're watching this video. So to get started, I've inserted the unit circle, and actually we'll flip back to it as we go through. Again, this is one we had created in class. Kind of flip back to it, so if you don't have yours, maybe you can see some of the things. So to get started, what I would suggest right now is possibly even going to pause the video for yourself and copy down this graph. So, all right, now that you've paused it and you have this ready to go, as you notice, what we're doing here, we're using the 30, 60, 90. When we're doing this, we're saying y equals the sine of theta. Theta is the input, so that's like our x. So what we're actually inputting here on this axis that's our theta. This is our y, right? So instead of theta, we have x. That's the angle. All right, so what we're going to do is look at what's the output of each one of these. So to start with, we're going to first put in 0, right? We put in 0 degrees. That's going to be right at this spot right here. That's 0 degrees. If you go back to what we talked about just on Friday, previous page here, as we did in class, remember the big revelation at the end was sine of theta is just the y coordinate on our unit circle. So if we go back here, our y coordinate for 0 degrees is 0. So that's a point. It is at 0. So we have actually, when theta is 0, y is 0. All right, now we go back to the second one. We're going to do 60 degrees. So 60 degrees, we're looking at the y coordinate, which is the square root of 3 over 2. Now if you have a calculator handy, you can take the square root of 3, divide it by 2. And if you take the square root of 3 and divide it by 2, you come up with like 0.866 and so forth. So on our graph, we can go over, whoops, I skipped 30. Let's do 30 first. Sorry. 30 degrees here. Y coordinate again. Y coordinate is a half. So, and then, so the y coordinate is a half, so we can plot this point. So that was the first one at 30. 60 was the 0.866. So somewhere in here, almost up to 1. All right, now if you graph 90 degrees, and actually do that as going back to your unit circle, that's the y, which is 1 for 90 degrees. So at 90, you get 1. So you have that point. So if you move on to 120 degrees, again, go back to your unit circle, you realize that the y coordinate is square root of 3 over 2 again, which is that 0.866. You might start to see some patterns now, or noticing some things. If you go on to 150, again, unit circle, at 150, the y coordinate here is 1/2. So at 150, we're back to a half. And then when you do 180 degrees, oops, excuse me, to go backwards, 180 degrees, y coordinate 0. So here we are at 0. So what we've done so far is graphed, between 0 and 180. Now we're going to move on to 210 degrees. So as you look at the unit circle, 210 degrees, y coordinate, negative 1/2. So 210, we're at negative 1/2. Plot that point. Moving on to 240. Keep going the wrong way there. 240. So back to 240 degrees on your unit circle, y coordinate, negative 3 over 2. We just said square root of 3 over 2. And the square root of 3 over 2 we said is 0.866. So now it's just negative. So what we have here is negative 0.866. So we plot about that point. Go on to 270. So when you go into 270, if you go back to your unit circle again, 270 y coordinates -1. So now we're down to -1. And then going on to 300, you're back at -0.866. Again, going to 330, you're at -1/2. And then when you come all the way back to 360, which is same as 0, we're back to 0. So your sine function actually looks like that. And it would continue on. So at this point, what we're going to talk about is, that would be the sine function. You could keep going from there. So next we'll move on to the cosine function. So that will be on the next slide. All right, so to continue our recording here, for our next part is the cosine function. So again, you probably want your unit circle, write this down. I would actually probably pause the video at this point to copy this part. So now again, we're going to graph y equals the cosine of theta. And so here's our y. This axis is going to be theta. So again, I'm going to flip back to the unit circle. We're going to start with making theta 0 degrees. And what you remember from the unit circle part, we're going to flip back 2 pages here, is cosine is just the x-coordinate. So when we look at this, all right, cosine of 0 degrees, that's 1. So we see over here, that's the 1. All right, so now we've got that. So that means on here, cosine of 30 degrees would actually start at 1. Now, or excuse me, of 0 degrees. Now you move on to the cosine of 30 degrees. So going back to your unit circle, you look at the x-coordinate, square root of 3 over 2, which is just 0.866 about. So going back 30 degrees, you're about 0.866. Go to 60 degrees, what you would notice again at 60 degrees, the x-coordinate is 1/2. So at 60 degrees, we're at 0.5. Now we're going to 90 degrees. So lastly, we go on to 90 degrees. You're at 0. All right, so back to 0. Now, if you just keep going, you realize, kind of thinking through this, what we had before, 120 degrees, what's going to actually happen then? What you'll have is the y-coordinate, in this case, at 120 degrees being, misspeaking here, the x-coordinate to be -1/2. So we're at -1/2. And as the pattern continues, just like with the sine function, 150 is going to be the -0.866. So in here, 180 degrees, you realize that the x-coordinate is -1. Going on to 210, you're back up to -0.866 about. 240, you're back up to -1/2. Moving on to 270, you realize that the x-coordinate there is 0. Right, so just to kind of confirm what we're at, notice we are at 0, -1/2. That was for 270, -1/2. And then over here we had -0.866. Again, what we had here was -0.866, -1/2, 0. And then, as you probably can guess, the next one is going to be +1/2. After that, we're at +0.866, and then all the way up to back up to 1. So the cosine function starting here, again, is a curve. And in this case, it's kind of curved in that way. Should be maybe a little more dramatic here, but you can see it goes down, comes back up. So if we're going to talk about the couple of things here, what we're going to do next is talk about the period and amplitude. So I really don't need all this information, so I might as well just delete all those things. So if we just take that and delete it. All right, so let's talk about the amplitude. Now, I'm not giving you a real scientific definition here, but it's going to just say, basically the way I think of it, or way to explain it is the distance, the graph ranges from the center. Now, if we look at each one of these functions, we go back to basically the sine function. The center here really is at, is going to be right here at 0, right? It's this middle part. The axis is kind of the middle. Now, notice how far up does it go? Well, it goes 1 unit. Actually goes down also 1 unit. So it goes 1 unit in each way from the middle. So that means the amplitude, right, for the sine function, y equal the sine of theta, has an amplitude is 1. All right, so let's talk about the cosine. So on your own here, you could probably look at this and take in your notes. You want to have, you know, basically those graphs in there. You look at the cosine, the amplitude is the distance it goes away from the center. So if we go back to the cosine function, you see right here, you know, here's our center again. It's basically that axis with our degrees, our theta. And you notice at this point, that's 1 unit. Here in the middle, it actually goes down at 180 degrees, it goes down, that's still 1 unit. Back over at that end is also 1. So notice it's varying 1 unit in each direction, which means then again its amplitude is 1. All right, so now let's go back and let's think about, so you've written down about the amplitude. We're going to talk about the period. Okay, here's again my kind of definition. It's basically what I think of is the time, and when I say time, I think of the coordinate, or the x distance, if you want to think about that. This is the way I look at it. The x distance to repeat. So if you do this, you will see that we go back to the sine function. Well, if we start at 0 here, it goes all the way up. It's back, it's up to 1, goes down to 0, but it hasn't actually repeated yet. It actually keeps going down and then back up again. It hasn't actually totally repeated. Now again, if you think 360, we would just start over at 30 degrees, blah, blah, and all the way through. So this is actually going from 0 to 360. So the period for the cosine function, or y equal the cosine of theta, the period is 360 degrees, or 2 pi. Now if you do the same thing for the sine function, right? We just actually that was for the sine function, excuse me. If you do it for the cosine, you'll notice the same thing as well. Starts at 1, goes all the way through. Okay, so the sine function, you know, starts at 1 and comes all the way down, goes back up. And those of you, that was Mrs. G just came in, so asking something. So that was the interruption there for a minute. But you can see here that that starts over, it goes from 0 to 360. So I didn't lie on the first one for the sine, and that the cosine was 360 or 2 pi. Turns out they both are. Now what we're going to talk about on Monday is how do we shift these things? How do the equations change when, how does the amplitude change when we kind of tweak these couple of items? So that's for Monday. Should have down these slides just kind of written down as notes. Have a good weekend. We'll see you then.